Welcome back to my series where I work through all 150 of the NeetCode 150 list. Today I'll be doing I'm actually not sure what problem this is. Okay, 73rd problem. And I'm going to be doing a graph problem today, which is exciting. I don't think I've done a graph problem on this channel yet. I've done a few of these. I would say I don't feel super confident with them. And yeah, so I'm just going to start off by reading the problem, and then I'll jump into solving it. So this one's called surrounded regions. And so you are given an MXN matrix board containing letters X and 0, or O. Capture regions that are surrounded. Connect. Okay, so I guess there's three, scenarios. So connect. A cell is connected to adjacent cells horizontally or vertically. Region. To form a region, connect every 0 cell, or O cell. Is that a 0? I swear that's a 0. Surround. Wait. Okay, I guess this is surround. The region is surrounded with X cells if you connect the region with X cells and none of the region cells are on the edge of the board. To capture a surrounded region, place all O's and X's in place within the original board. You do not need to return anything. Okay, and so here's an example here. So we have this input board, and let me just check that my OBS is working. I got a second monitor, so it's very nice I get to do two things at once. Okay, so we have two things here. We have, our input board and then our output board. Okay, and so this is a surrounded island and a region, and we can take it. And why can't we take this? Okay, none of the region cells are on the edge of the board. Okay. Alright. Cool. So, like usual, I'm going to copy and paste the example into my OneNote, and then I'll start graphically working through the solution. Okay. So, we start like this, and we end up like this. And we want to take this section, and we can't take this section because it's sharing an edge with the board. So I guess I wonder if we can reframe the problem to be like, find all of the 0 or O's that are somehow connected to the board. I mean, to the edge of the board, and then we can just replace everything else except for those regions with X's. And this would be like an O in squared solution, I think. Something like that. Because what we would do is we would run a DFS or a BFS on every single island. And if the island has any section that is connected to the edge of the board, then we want to exclude all of the coordinates of that island. Okay, so that's interesting. How are we gonna do that? Or we could keep track of which ones we can include. That's our two options here. I think you can probably do both ways, but first let me just define what makes something not usable. So if it has, so anything that's 0, 0, 0, 1, 0, 2, 0, 3, so that would be just 0 to n for n, right, C for Cn range false. Otherwise it'd be 0, 0, 1, 0, 2, 0, 3, 0, which would be R0 for R in range rows. And then I think the reverse would be true. It'd be we'd have calls -1 C for for C in range calls, and rows R rows -1 for R in range rows. So if any of our cells, if any of our islands have regions here, whoops. Yep, so if any of our regions have cells in any of these cells, like coordinates, then we cannot take that region. Otherwise, we can. Okay, so alright, so that would be like our case. And now we just need to figure out some way to collect all of the regions into one, like we need to sort of like map them out somehow so we know, okay, like this is this region and this is this region. So what can we do? I guess we could first put all of the coordinates in the whole board into a set, and we could then iterate until we hit an O that is in one of these areas, and if we do that, then we need to find all of the coordinates that O is connected to and remove them from the set. And then when we're done, then we want to set everything to 0 or everything else to X. Okay, I think that's actually relatively straightforward because we can just do that with a DFS or a BFS. Okay, let me just think about this. So first off, I'll create a set of all coordinates. And what are we gonna add into the coordinates? And I'll go. Oops. Uh, Alright, so this is gonna be our set of, oh wait, I just realized I need to move my drawings. So I'm gonna put this here, and hopefully you can see that. And it, on my screen, it kind of looks like this is very washed out and like very like white, and I don't know why, but I'm just gonna leave it because I don't know how to change it. Okay, so that's what we're gonna do. We're gonna add everything into the set, and then what? And then we are going to add everything into the coordinate set. So we can do that by, I think there's a way, like, hold on. I think it's like, okay. This could work, maybe. Either way, it's gonna be the same time complexity, but let's just go. No, this is silly. um, I'm just gonna do it the like brute force way. Okay, so that will add all possible like coordinates, oops, into the valid set. And oops. Something is wrong here, actually. I'm getting a suspicious vibe because we can't just okay. I'm gonna change that from valid to chords because and I'm actually just gonna call this edge. Oops. And yeah, valid. I'll call this one valid. So this is gonna contain the set of all valid coordinates, like the ones that we can set to an x, and we're gonna go through everything. Oh, actually, we actually don't even have to do this more than once. So we can either add something to the set or not. Actually, I'm going to do it this way, but I think that there's probably a way to do it in the first nested for loop. But anyway, okay, so now what we're gonna do is for RC and valid. Actually, no, this makes more. Oh, I don't know. Anyway, if uh if board RC equals O, is that really an O? It really looks like a 0. Okay, yeah, it is. Then we want to do a DFS, so I'm gonna have to make a helper function. Uh, I'm gonna change it to a BFS. And what are we gonna have in there? We're gonna have to pass through. Let's see. Oops. Okay. Now we're gonna have to import a deck. All right. Now we'll have to go while here, and if we have, we'll go q.pop left. If board c equals 0, then we can continue, and we want to get directions. So we'll need a list. We need a dictionary of directions. Let's go. That up here is a global variable. This just makes it easier to iterate through all the changes. For the and I'll add this as a non-workload too. I don't know if we'll need rows and calls, but anyway, I'll just keep it there. Okay, so for the nr and c equals r plus dr c plus dc. And now what? Okay, so now we're looking in every direction. And we're also gonna keep the invalid set. Seems a little, I don't know if that's actually necessary, but I'm just gonna leave it for now, and then I'll see what happens if I remove it. Anyway, okay, so now what? Now what? Now we're gonna check if nr and c in bold, so this is the equivalent to it being not invisited. Then we want to determine if it's invalid. Wait a minute. Hold up. What are we actually doing here? So, okay, let me think about this more. Let's change this. Let's say that we had this case where like this is an O as well. So then we would want to like keep everything. Alright, so what we would do is we would go, okay, like iterate everything, then we get here. Okay, and then we see we have a Q, which is gonna be what's that? 0, 2, 3, 0, 2. It's gonna be 3, 1. Is in our queue, and then we'll pop that, we'll get 3, 1. And now we want to look for everything attached to 3, 1. And so we'll see, okay, yes. We only want to add it to, we only want to do a BFS if it's on the edge. And RC invalid. Whoops. Alright, because that's when we want to start our search. Okay. And then do we want to go ahead and set board RC to X then? And then we can just set everything else from the BFS? I'm not sure. But okay, let's just say that we do that. So we get 3, 1. Okay. And then we'll see, we'll want to be looking at, 3, 0, 2, 1, 3, negative 1. So, no, 4, 1, which is invalid completely. And what's the other one? 3, 2. Okay. And of these, only this one is something that we want to search. This is completely invalid. And yeah, okay. Alright, so we want to look and see if grid is something that we want to search. And and we aren't changing it necessarily, I don't think. Not invalid. And boards. We can probably actually modify it through just this, now that I'm thinking. Like, we can probably just go like, if it's a 0, then we can just make it an X. Yeah. Because we know that it's going to be attached to something that it shouldn't be. And this will automatically treat it as if it's visited. So then we can just swap these around, so that will be the equivalent of adding this to the visited set, and then running BFS from there. So what that will do is, if I draw this out, I'm going to just redraw it. Wow, this might be the quickest I've ever solved a graph problem. Okay, I'm just going to redraw this exact case here. And I'll just do 2 different colors like it is here. X, 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 X. And then this will be, and I'll make that purple just. Alright, so what will happen is we will iterate over all of these until we get here. And then we'll see, okay, this is on the edge, so we definitely need to search it because it's a 0, or because it's an O. And so once we're here, first we're going to set it to an X, And then we're going to look, is that a 0 or is that an O? No. Is this an O? No. This one is an O, so we need to change it to an X, and we need to search its neighbors. So that's what we're doing. And now we're here. We're going to pop that from the queue. So our queue will look like 3, 1. And so we pop that, and then we get 2, 1. And then we're popping that. And we're going to go, okay, is that an O? No. Is this an O? Yes. So we'll add 1, 1 into the queue. And then we'll go, is that an O? Yes. So we'll add 2, 1, 2. No. Yes. 2, 2 into the queue. And then we will end up popping 1, 1 first. And we'll go, okay, is that an O? No. Is this an O? No. This one is an O. So we'll need to add, what's that? 0, 1. 1, 2 into the queue. And then we'll pop 2, 2 from the queue. And we'll go, oh, and we'll make that one an X as well, I think. Yeah, because we make everything an X before we add it to queue. So then we'll be here, oh, and this will be an X too. So then we'll be here, and that's an X, that's an X, that's an X, and that's an X. So, and that is going to be the end of our queue. So I think that this should work. All right, and we just have to do a grounds check. All right, cool. So I think this should work. Just thinking of any edge cases here. And yeah, I'm pretty sure that I can get rid of this, but I'm gonna run it first to check it out. Whoops, unknown network. Oh. Whoops. Also, I don't really need this. What? Oh. Just have some syntax errors. Did I do this to every single set add? Yes, I did. Every single one. That's crazy. Okay. Well. Okay, so it didn't work. Why didn't that work? This is literally that case. Oh, put it into... Okay, so I need to run this through the, like, default, or, like, the first case that they show. Okay. I'm hoping this isn't too much of, like, too much missing. I think it shouldn't be. Because I feel like my logic is relatively solid. It might just be like I implemented something weirdly. Okay. So, oops. So in this case, what we would do, we'd have, okay, I wonder also, what is my edge, like, is there something wrong with my edges? I don't think so. Should be right. Okay, alright, so we iterate over until we get to here, and that is a 0, and our C should be in edges. So then we go and set that to an X, and we go BFS RC K. Am I accidentally getting like diagonals or something? I don't know. Okay. So then we'll go, okay, that is not valid, so we're not checking that. This is not an O, so we don't do anything. That's not an O, so we don't do anything. That's not, okay. There must be a syntax error here. Oh, oh, oh. No. Okay. Okay. So that's weird. What's going wrong in here? What is going wrong? Let's just do this the old-fashioned way. Okay, well, yeah, we can definitely get rid of this. I'm pretty sure. But I just don't see why this is getting called. It must be something to do with my edges. Okay. Since I'm on a time constraint here, I will be cheating. Okay, yep, there was something wrong with my edges. I think I need to swap these. I'm not sure why. Oh, I know why. Wait, yeah, okay, actually, hold on, I see. This doesn't make any sense. It has to be this. And I didn't read the full solution that ChatGPT gave me. I just read this. Okay, just putting that out there. Alright, let's just see if that works. Okay, no, it doesn't work still. Okay, well, what the heck? What the heck? What is that? I don't see why. I'm gonna try like a simpler case. What do I edit? Oh, okay. So I'm just gonna reduce this to like a 3x3 board. And then I'll try like a 2x2 as well. Because in the 2x2, nothing should ever get changed. So let's try that. Okay, right. So in the 2x2 even, things are getting changed for some reason. What's wrong? Well, how come you can connect this? Oh, okay, I see. I see, I see. I'm just gonna think for a bit more, I think. Just gonna... So, let's just go through my code line by line. Seems to be the best way to fix things most of the time. So I'll start with the 2x2 board, which is like the most simple case ever. Oops. Well, I mean the 1x1 is the most simple case, but 2x2 is a bit easier to like comprehend. And I'll just go like 0, 0, x, x. Okay. And what we're gonna do is we're gonna have edges. It's gonna be our set, and it's gonna contain, and cols is gonna equal 2, rows is gonna equal 2. So we'll get, so for the first for loop, we'll start with 0, C is gonna be 0, then we'll get 0, no, we'll get, alright, yeah, and we'll get, 1 and 0, and then we will get, for cols is equal to 1, we'll get 0, 1, and 1, 1, so that will give us this, that, which is everything, but I'll go through the rows too. And then rows will give us, r is going to be equal to 0, and we'll get 0, 0, and obviously this is a set, so that won't be counted, and then we'll get, 1, oh, so 0, 1, and yeah, that won't be included, and then we'll get 1, 0, and then we'll get 1, 1. I think, yeah. Okay, so that's everything. That's literally every single coordinate in our graph. So, oh, that's the problem. Okay, I found the issue here. It's that we need to be looking for like not in edges for the ones that we want to flip, not the ones that are in the edge, unless we want to keep the coordinates of what we don't want to change. So, okay, we can't flip this. Instead, we have to add this into a set of set. Okay. And then everything outside of this set can be flipped, and I'll have to define it up here. First, I'm actually just gonna like run this to see what happens if I don't declare a non-local variable. Okay, it looks like it still runs. So, okay. We'll go invalid. Instead of doing this, we're gonna do invalid.add nr and c. And then we'll go invalid.add rc. And then what we're gonna do is iterate through it again. We'll do that, and that should work, I think. Yeah. Okay, so I'm guessing there's like a better way to do this where you don't have to iterate it through it like 3 times. I'm just gonna go ahead and submit this. And this would be an O(n) squared solution, I believe, because we're iterating through the board and column twice. And now, yeah, I'm trying to think. Oh. What? Why did that not work? That doesn't even make sense. Oh. We never did the check. That would be why. I think. Yep. Gotta do the goal check. Okay, yeah, sweet. So that's my solution. I'm guessing that there's maybe a better way to do it. Actually, I'm gonna call it a day. I have some assignments due. So, yeah. Thank you for watching. If you're interested in following along with my journey completing the NeetCode 150, feel free to subscribe, as I will be posting more of these videos over time. And yeah,